And week 3, day 4 is a go. Let's get started. So last time we did a stock picker and we just have a little tiny bit more to put into that. And then we're going to move on with our next project, a developer agent. But first, another repetition. I hate to repeat these things, but sometimes it's good to drum it in. Building a crew project involves 5 things. First of all, Crew AI, create crew, the name of the project to set up your crew, build those directories and those files. Number 2, you find the YAML files for your agents and tasks and you fill them in to define your agents and tasks. Number 3, you go to the crew.py module, which is where you actually create the instances, and you use decorators to identify the agents and tasks that you'll be using, and then you create your crew itself. And this is where you can have structured outputs to make sure that the outputs conform to a schema, and you can use tools, both tools like Serper that Crew provides for us that run remotely, and then custom tools that we build locally, like the thing that sends a push notification. And then number 4, you update main.py to set any inputs so that we can pass something in, configure the fields that are templated with the curlies. And finally, we run with Crew AI run, and off goes our project. So I now want to cover a feature of Crew called memory. And this is a feature that is a bit more prescriptive, a bit more opinionated in the Crew framework. Memory, of course, is talking about how you provide information, contextual information to LLMs each time you call them. And in Crew, you can implement that yourself just by storing variables and then passing them in when you do things like creating tasks. So you can do it the sort of manual way. But the Crew framework also comes with some building blocks that lets you use their constructs around memory out of the box. And that comes with pros and cons. The pro is that you get up and running quickly and you can use a lot of the thinking that they put behind this. The con is that there's a learning curve and it obscures some of the detail of how prompts actually work behind the scenes. So as with many times when you're adopting a framework like this, it's something to be aware of the benefits and the trade-offs of doing so. But let's say that we are going to embrace Crew's way of handling memory and talk about what it actually does. Well, it has 5 different types of memory, 5 different frameworks that you can include. And one of them is called short-term memory. And this is just about storing recent interactions using a vector database in a RAG way, if you're familiar with retrieval augmented generation. And you don't need to be for this course because we're just going to put the code in there and see it run. But if you do know, then this will make more sense. So this will allow agents to access recent relevant information when they are currently executing. And then a different concept called long-term memory is when more important information is stored in a SQL database for longer-term recall to build up knowledge over a sort of longer period of time. And then there's something called entity memory that's very similar to short-term memory, actually. It's basically when there's things about people, places, and concepts, then those can also be stored in a RAG database for vector-based similarity search and to be included in the context. And then there's Crew describes this as another kind of memory, but I think it's a bit misleading. I think what they call contextual memory is just a sort of umbrella term for the short-term, long-term, and entity memory that can all together be queried and passed in as context when prompting an LLM. And Crew abstracts all this away from you, so it's just going to be a few lines of code to have all of these types of memories running. But in doing so, as I say, big benefit, a lot of work happens behind the scenes. And perhaps also there, the trade-off is that you've got less visibility into it. So if things don't go the way you want, then it's a bit harder to debug and figure out what's going on. And then there is another kind of memory called user memory, which is to store user-specific information. And actually, at least as of now in Crew, this is a concept that they support and have some frameworks around, but it's mostly left up to you to be querying user memory and then inserting it into the prompt or providing it at the right time. So user memory is a bit of an odd one out here, and I suspect that they're looking to build more into that in time. And for now, for the code that we're about to look at, we're just going to really look at contextual memory, so short-term, long-term, and entity memory, and seeing how we can incorporate that into our stock picker solution. And so we're back in the stock picker project in Casa, and we are looking at the crew.py module. And I'm going to start by putting in some new imports in here, which are interesting ones. From Crew AI memory, we're going to import long-term memory, short-term memory, and entity memory, the three types we'll be working with. And I do believe you can also have user memory in there too, but then you have to manually manage it yourself. And then from CrewAI Memory Storage RAG Storage, we're importing a class called RAG Storage for vector-based retrieval. And with that, we're also going to import from long-term memory SQLite storage, a long-term memory SQLite storage object like that, a class. All right, so that's a few things that we're now going to put to good use. We're now going to go to the crew function, the function that creates the crew within this module. And you can see where we made our manager, and we've got a few more things to make as Cursor is trying to prompt us there, trying to ignore Cursor's insisting. Let's do it ourselves. All right, so we are going to want to be creating a short-term memory, a long-term memory, and an entity memory. And we're going to do them one by one. So let's start by saying that the short-term memory, which is the one that we'll begin with, short-term memory. Try not to press a tab or it's going to fill it all in for me, but I'm going to do it right here. Short-term memory is going to be something which has RAG storage. We come up with a provider, which is OpenAI, and a model, an embedding model to generate vectors from text. And we'll be using this one, and you can substitute in whatever models you would like here. It's going to be short term, and we give it a path to where we'd like it to create that memory, that vector store, as /memory. And it will use Chroma as it happens, something which people who've taken my LLM engineering course know very well. I love Chroma. All right, so that's the short-term memory. Let's also create some long-term memory. So here it is. The long-term memory is going to be just simply creating an instance of this class, long-term memory SQLite storage. And we'll give that also a place to go. We'll make a database file also in the same directory. So that's the long-term memory object. And now, finally, thirdly, we're going to create a entity memory object. So entity memory, and there it is. So I see. Hang on, we've got two of them. Let's do that. Looks like that's good. So entity memory is going to be an entity memory object. It's also going to be a RAG storage object. We give the provider and the embeddings model, and we put it in the memory folder. So here we have our three types, our short-term memory, our long-term memory, and our entity memory. And now we get to the place where we create our crew. And now it's going to be very challenging. It's not going to be challenging at all. We're going to say memory equals true. And we are going to then just do exactly that. So crew was a little bit off base with the memory equals part, but it's got the rest of it right. That's all you need to do. You set the long-term memory, the short-term memory, and the entity memory. And we are almost done with memory, just as simple as that. And I said almost because there is just one, or rather two, very small extra changes we need to make. We need to go back up in the module to where we created these agents, the trending company, the financial researcher, and the stock picker, and we need to give them memory. Now, what we want is for the trending company finder to have memory, and we just do it by saying memory equals true. We don't actually want the researcher to have memory because we want it to go and do research every time. But we do want the stock picker to have memory because we don't want it to recommend the same thing more than once. And I don't know if you remember, but in the prompts, in the YAML files, I said a couple of times, don't recommend the same stock twice and things like that, and surface new companies for the trending company finder. And that would normally be the final change you need to make, is go back and make sure that your instructions and your YAML files are very clearly making sure that it will take advantage of memory. Because remember, whilst memory, these abstractions are trying to make memory seem quite magical and taken care of for you, at the end of the day, memory just means more stuff shoved into the prompt, more relevant context put into the prompt, so that when you call an LLM, it has knowledge, it's in the input is included information about prior conversations or about prior information that it retrieved. So with that, we have set up the memory, and we are now going to bring up our terminal and then run this. And so as usual, I go into, we're already in the stock picker. So all I have to do is type CrewAI run and we'll be good to go. Let's see what happens. So just right off the bat, we expect it to be able to take advantage of memory without needing anything more. what we should see is it should create a memory directory in here, and it just has, there is a memory directory. Stuff is going on. My computer is hard at work, and I can see already within memory, there is a Chroma database that's being created. There is a long-term memory. If I expand this, there is indeed a database that's been a SQLite database that's been created there. And so things are happening. And we can see that various companies are being surfaced by the market watcher, and more is going on. And we will let this thing run. My computer's hard at work, and I will see you when we have a conclusion. And that definitely took a bit longer. It was going around the houses a little bit, but it completed. It recommended Microsoft this time. Remember, don't use this for real decisions. But it was entertaining to see it at work and bouncing around between the different agents. And whilst we don't have as much visibility into what's happening in terms of its use of memory and what context got provided, we can see that it certainly built and populated different data stores, and both the short-term memory, the long-term memory, and the entity memory in the RAG Chroma data store that's been created there. And the main point I want to get across is that, of course, you can see the benefits of what this brings us. It was so easy to set up quite a complex situation, multiple types of memory with both vector similarity queries and SQL queries too. And we didn't need to know anything about it. We simply created the objects, the short-term, long-term entity memory objects, passed them in, and then we told our agents, we turned memory on by saying memory equals true for the agents that we wanted to remember things. And that is a wrap on the Stock Picker project. We saw a lot of different aspects of Crew AI with this project. Reminder, we saw structured outputs. We saw our own homegrown tool as well as SERPA. We also used not the sequential, but the hierarchical process. And now we have added in the memory feature, all three main types of memory in there as well. And that is a nice tour of a lot of the functionality in Crew. And now for something completely different. We are going to work on making an agent that knows how to code, how to write Python code, how to write software. And a little bit more than that, it's not only going to know how to write software, but how to run it as well. So this is challenging and complex, but it's possible to have an agent in the Crew environment, which has this ability. Not only is it able to take a problem that you set it can write code to solve that problem. It can then execute that code in a Docker container. It doesn't need to, but it's good to have it run it in a Docker container, which means that it is in a sort of sandboxed, ring-fenced environment that doesn't have access to do damage to your computer because it's in this protected world. And then it can run the code, it can execute it in that container and look at the results and interpret those results to take on some more action. So as I say, this is a really advanced task. This is something that's taking us to the next level, and it's going to be hard and complex, except it's not going to be hard or complex. You probably saw it coming. But it is going to be as simple as when we create an agent, we're going to say allow code execution equals true. And that's going to be it. And then it's going to be able to execute code. And if you say code execution mode equals safe, then if you have Docker installed on your system, and I will show you how to install Docker if you don't, it will run it in a Docker container. And it seems almost so good. It's crazy. I had to close down Docker to make sure that it failed when it was closed, because I almost couldn't believe it was happening. It's that simple. And this is where frameworks like Crew really stand out, because they make things like this so very easy to do. It's worth mentioning that this kind of system is sometimes called a CODA agent. There's various other names for it you hear. And it's worth knowing that when people talk about CODA agents, they're not just talking about agents that can deliver code, agents that are able to generate Python, but also this ability to generate Python and then run that Python as steps towards solving a greater problem. So that this is more a means to an end than just saying it is something which writes code. Now, confusingly, our project for this week, we are going to build something that writes code, but the fact that it can run it too is kind of cool. So that is the introduction. And with that, let's go and actually build something like this. Let's build something that can write it. We'll make something that can write code and can run it. Let's do that. See you in a sec. Okay, welcome back to Cursor. Welcome back to the crew folder. And I'm going to open up a new terminal and go into that third folder. And you know how to create a crew project so well now that you have it committed to memory, but you know that it's crew AI, which I can't spell, crew AI, create, crew, and then the name of the project, which we will call Coda. And it's going to build the directories. It's going to do the scaffolding. Oh, we have to say that we want OpenAI and we want GPT-4o Mini and we don't need a key. And kabam, we have all of the folder structure. Great. Okay, so as always, the first thing we do is we go into the config and we start by defining our agents. So what agents are we going to have? We're only going to have one this time. It's going to be a very simple agent. Let me just remove this so that we can see what we're doing. Let's delete the scaffolding and put in our Coda agent. So we're going to say you're a Python developer. That's the role. You write Python code to achieve this assignment. And then we pass in the assignment. That is the input that will be set in the run method. First, you plan how the code will work. Then you write the code. Then you run it and check the output. Backstory, a seasoned Python developer with a knack for writing clean, efficient code. And we can use GPT-4o Mini. Yes, you can do it either way, but we'll do what Cursor suggests. Change it to have the provider and the name of the model, which looks a bit better. Okay, so there we go. That's pretty simple. That was our single agent, and we're going to have one single task. Let's put it in here. It is write Python code to achieve this assignment. A text file that includes the code. So the output we want from it is a text file that includes the code and the output of the code. We want it to put both in the output. So I've called it code and output.txt as the output. So that is what we want it to do. So that's because I really want to make the point that it's going to write code, run it, get the output, and it's going to think all of this through and then respond with all of that. We don't just want it to give us the output because we want to double check what it's doing is right. Okay, now we know we have to go to the crew module. Let's do that next. Okay, here we are in the crew module that I've just gone through and deleted the templatey stuff that's in there by default. And so we're just leaving our config relationships here. And I'm just going to put in a little comment here. Make that a comment as well. Whoops. So this is a link to how you can install Docker if you don't already have it installed. And this, it's just literally, this is the Docker desktop web page for you. And as it does claim, it is a one-click install for Mac or Windows or Linux, and it should be as simple as that. Many of you, I suspect, from an engineering background already know and love Docker. If you don't, then welcome to it. This should be as simple as installing it, and then it's installed, and you can then leave it be. But you will need to have it installed for this to work properly in a Docker setting. Okay, so now we are going to create our agent. We start with an agent decorator to make sure it goes in the right place. And we are going to create a coda. I'm going to ignore the fact that Cursor is already probably several steps ahead of me, rendering my job here useless, but we'll keep going anyway. I'm going to return an agent. This is the usual fare. So what is our agent going to do? Well, we'll press tab there. The config is going to be the config that we set in the YAML file, but then we'll have verbose being true as usual. Now, what else do we want? We now want this super complex, super hard step of making sure that this agent has the power to run, to execute code, which is as simple as allow code execution equals true. There it is. Now it can execute code. There's this step of saying code execution mode is safe. And now that ensures that it runs it within a Docker container so that it's not just running the code on your platform. Now we can say max execution time. This is a good one to have in there. And we're going to say 30 seconds. This is going to be a simple task. And max retry limit. It's funny that Cursor prompted me wrong there. Let's give it 5 retries. It can have up to 5 times of trying this. And that is our coda agent. So now we have a task, and the task is going to be a coding task. And I rather suspect that we can just use what cursor does, but we can take out expected output because we already defined the expected output in the task itself. So that's not needed again. All right, so there we go. We have our agent and our task defined. Now we just have to do the crew function method just below. Well, this might be a bit of an anticlimax of just saying we have to write our crew function. We don't have to write our crew function because the default thing there is all that we need. We don't need to do anything else. We've already got something which can do exactly what we want. What we do need to do still is come into main and rewrite this. And of course, it's got all of the usual stuff. We don't need any of the stuff that's there. We'll just delete everything and come back here and write our own run function. Def run. This is the thing that's going to run the crew. And so we are going to say inputs equals assignment. How do I spell assignment? Assignment. There we go. Colon. Let's just give that a variable assignment for now. And then we're going to say results equals coda dot crew dot kickoff, passing in those inputs. And then we want to print result dot raw is how the result will come back. And then we will indeed have, no, we don't need that main in there because it will automatically run that for us. Okay, and so what's left to do, of course, is to set the actual assignment. So let's come up with assignment. Assignment, and we're going to do something challenging here because I want to check. If I said something like the default that cursor's got for us there, write a Python script that prints hello world, then we might not know for sure that it's actually running it because LLMs are perfectly capable of knowing what a script like that would yield, would result in. So it could generate the Python code and then pretend it ran it. So we want something that it can't do any pretending for. And so I have one thing to show you, although knowing LLMs, it probably could pretend this as well, but I certainly think this is a harder one. So I wanted to write a Python program to calculate the first 10,000 terms of this series, multiplying the total by 4. So I put it in quite a complicated way. And here's the series: 1 minus a third plus a fifth minus a seventh plus ... And so I'm just kind of, it's a classic case of just sort of asking the LLM to figure it out like a reasonable, intelligent human would. And who would have thought a few years ago that you could write software that would be able to take something like this with all of the nuance, all of the implications, and figure out that it needs to write code to put this into a loop to keep it going for 10,000 terms, and then to take the total and multiply it by 4. And the Mathmos around will probably have already spotted this as being a very slow and very boring way to calculate pi. So if it does this right, and if it calculates the first 10,000 terms and multiplies by 4, then it will be an approximation, a bad approximation of pi. And now, the LLMs are perfectly capable of recognizing this formula and knowing that the answer should be pi. But what's much harder is for them to realize that 10,000 terms would be approximately pi. It would be wrong after a few decimal places. And so that's how we can tell that it's really doing its thing. So I hope that all makes sense. It's time for us to actually run this. All right, everyone, this is exciting. The drum roll, we're going to try and have our coda do its thing. So let's bring up a terminal. Let's go into the third directory. Let's go into Coda and let's type crew AI run to kick this off. And remember, the challenge is now being set to our agent. You can see it started. There's the command, and it's now going to be thinking about it. And something just ran and failed in the code interpreter. So it's that one means it's its first try, and it's trying again. So it's not like it always works. At least it shows us that something is trying to run in an interpreter. Okay, it's done some code, it's got an answer, it just all happened really fast. So this is the code that it's got, that it's written, and this is the output. It's used an interesting technique. I can see it's obviously it's going through the number of terms as it should do. It's a number of terms it sets down below. That's nicely done. And then it's using this idea of take -1 to the power of the index, which is either going to be -1 or +1. That's a clever trick. And dividing by that, which looks right to me. And then where do we see it multiplying the result by 4? There, right there. I was going to say that would be suspicious. It does indeed multiply the result by 4, and that's why we get 3.14149, not 3.14159, because it is just an approximation of pi, and it seems to have worked. And indeed, if also we see that it's created an output file, yes, it has. And here in the output file, we will find the same output, which has got the code, the output below it. And I got to tell you, I'm blown away by how easy it is to do this and all of the machinery that's happening behind the scenes to be able to start a Docker container, come up with the code, run the code, come up with the answer. To the way that I expressed it in quite a simplistic way, it just figured the whole thing out. And I think that's really cool. And there you have it. We just gave coding skills to an agent. We have our Coder agent, and it was so simple. And I hope you enjoyed it as much as I did. All right, well, it ain't over yet. We've got more to go, because the natural extension, now that we've got a coder, we can build an entire engineering team. It's really, there goes in the meaning of crew. We're going to build a crew, an engineering crew, to be able to solve problems front to back, and it's going to be so great. I'll see you then.